Hi guys, today I want to talk to you about the quotient rule, the third of our big three new rules that we've learned in calculus. Now, if you've got an expression like this one here, 3x minus 2 over 4x plus 2, we don't have a technique at the moment that enables us to find the derivative of that. Certainly what we cannot do is just find the derivative of the top, which would be 3, the derivative of the bottom, which would be 4, and so that the answer is 3/4. The derivative of this certainly is not 3/4. So we need something new, and it's called the quotient rule. And here it is up here. So if we've got an equation or a function that is a rational in nature or an algebraic fraction that takes the form of u over v, the derivative of that will simply equal v. So start at the bottom with the v, write it down, then things fall into place. It's times u upstairs and the derivative of that minus the inverse of what I've just said, so u v dash. It's a bit like the product rule, isn't it, except there's a minus sign instead of a positive sign for the product rule, and also the order here would be important. You must start with the v downstairs, the easy bit, then the inverse of that, u dash minus u v dash, and all over, this is another difference from the product rule, all over v squared. Okay, so let's have a look at this, our first example. Filling in the bits, well, u is definitely equal to 3x minus 2. 3x minus 2. And u dash will equal simply the derivative of that, which is 3. And v is equal to the denominator, so that's 4x plus 2. And the derivative of that is simply 4. Now notice what's going on, or what we're required to do. It's v u dash. Where is v and where is u dash? Well, there's v, there's u dash. So it's going to be that times that, isn't it? Minus that times that, or the other way round. Now it's my habit to write down the shorter of the two expressions first. So in other words, I'd write, instead of v u dash, I'd write u dash v. That's just a little tip, and instead of u v dash, I'd write v dash u. Okay, so let's have a look and see what we get. Okay, so dy dx will equal, now vu dash is equal to 3 lots of 4x plus 2 minus, always minus there, 4 bracket 3x minus 2, and that is all over what? V squared. Well, v is simply 4x plus 2, and I'm not going to, I always like these expanded, boys, these expressions, but I'm not going to do that just yet. Okay, so the rest is just collecting like terms and so forth, so let's do that. Let's get that out of the way a bit and give us ourselves some extra room. So therefore, dy dx will equal, just expanding the brackets upstairs, that's 12x plus 6 minus 12x plus 8, being careful of the double negatives there, all over. Now I'm not going to expand this just yet. I'll leave it till the last line of working, like so. Okay, so here is the last line coming up now. Dy dx will equal, the 12x's knock each other out, and 6 plus 8 is clearly 14, over, now we've got a perfect square here. You'll always have a perfect square, won't you, down the bottom, because it's v squared. 4x all squared is 16x squared, so it's the first term squared, plus twice the product of the inside terms, so 2 times 4 is 8, 8 times 2 is 16, so it'll be 16x, and plus 4. Now, it so turns out that you could factorise this a little bit in terms of 2. 2 is a common factor for each term, isn't it? But that's not the point of the exercise generally, so I'll be happy if you get it down there. But I'm feeling a little bit OCD about it, so I will call it 7 over 8x squared plus 8x plus 2. Okay, that's the final answer. As I say, I'm quite happy with that as an answer, but this is that's perfection, that one there. Now for the second example, you might want to press pause in fact and have a go at it yourself and then check in once you've had a go. So here u is quite clearly 4x squared minus 1, and u dash, the derivative of u, is going to be 8x, isn't it? Okay, so v, well, v's right there, it's 3x cubed plus 2x, and the derivative of v is going to be 9x squared plus 2. Now remember what the template was suggesting. It is vu dash, the derivative is vu dash, subtract u v dash. So it's that sort of cross multiplication that's going to go on. Okay, so let's move that up a bit and have a go at this. Therefore, dy dx will equal vu dash is equal to, I like to write the shorter of the two expressions first, 3x cubed plus 2x like that, and minus, always minus, the uv dash. So it's 4x squared minus 1 bracket 9x squared plus 2 close bracket all over v squared. Okay, now I'm not going to write 3x cubed plus 2x just yet, all squared down there, no need to. Okay, what have we got now? We've got some expanding to do. Dy dx will equal 24x to the power of 4 plus 16x squared. Now we've got a bit of a binomial expansion going on here, so I'm going to put that in brackets. It's 4x squared. You can use FOIL here, just to repeat that. FOIL. And what I'm talking about is expanding this binomial product here. Okay, so the first terms are 4x squared times 9x squared, so it's 36x to the power of 4. The outside terms are 4x squared times 2 is plus 8x squared. Then the inside terms, negative 1 times 9x squared is minus 9x squared. And your last terms are negative 1 times 2 is negative 2. And let's just put all that over v squared again. Again, we're not too troubled about expanding it just yet. So therefore, lost my pen. Therefore, dy dx equals. Let's just get rid of the brackets on the numerator. So it's 24 x to the power of 4 plus 16x squared minus 36 x to the power of 4 minus 8x squared. Remember, the effect of a negative sign outside of brackets is to change the sign of everything inside the brackets. So moving on, we get plus 9x squared plus 2 all over v squared. Okay, so let's make ourselves some room and continue. What have we got now? Well, there's a bit that can be cancelled out there, dy dx. I like to deal with the highest powers of x first and then work my way down. So we've got two terms with x to the power of 4 in them. They are there and there. So let's collect those together and you'll get negative 12x to the power of 4. So negative 12x to the power of 4. Now the x squared terms, I've got a few of those. I've got negative 8 plus 9, so that's plus 1, and then plus 16x squared there is plus 16, that is plus 17x squared, 17, well, let's make that clearer I think, plus 17x squared. So that's the x squared and x to the power of 4 terms. Now we've just got 2 left over, I do believe, so plus 2. There were no terms with just x in them, were there? And that's all over v squared. Now would be a good time to square v. Now let's have a look. We've kind of lost it. It was 3x cubed plus 2x all squared. It's just up here. See, that was v there. Remember, v u dash. Okay, so let's just expand that. Now that's going to be a perfect square because it's v all squared, so 3x cubed plus 2x. So how do we do that again? Well, it's the first term squared, so that's going to be 3 times 3 is 9. X cubed squared is x to the power of 6, plus twice the product of the inside terms. What does that mean? Well, it means 2 times 3 times 2. 2 times 3 is 6, times another 2 is 12. X to the power of 4? Oops, 12 x to the power of 4. And finally, the last term squared, well, 2x times 2x is 4x squared. And that is our second example. Thanks and goodbye.